Today I'm going to be showing you an alternate way of doing triplanar mapping using a slightly different method for working with normals. This is an example of some of the results that you can achieve. You can have it based on the world rotation, or you can have it based on local, so that everything stays fixed. Sometimes you're just trying to make a simple material like this rust material, and you don't need it to be perfectly triplanar mapped. In which case, this method will probably be pretty good for you. You can see though it does have some disadvantages. If you look closely, you can see the seams where it starts switching to different coordinate systems. But I'll show you how that all works here in a moment. Coming out of play mode, I have it put into a subgraph right now. So if you want to just copy it right now, you can hit pause on the video, but I will be walking you through it later. And then this subgraph produces a UV, which then you can implement it into any procedural material you have bake-in. So if I was to be using typical triplanar mapping methods, I would have to basically duplicate all of this 3 times, or have 3 in total, with a different variation plugged in. But with this method, I only need to do everything once, and it just has 1 UV. So I won't be showing you how to make the metal material, but this is just about the triplanar mapping. So the way it works is you take the normal direction of every single vertice, and you normalize it, and then you get its absolute value, which means it only goes between 0 and 1, and then, as you can see, you split the X and the Y, and lerp them with like the inverse coordinate from the object's position. So also the only difference between this material's the reason why it's doing that instead of staying perfectly in the same place is because the only difference between there is these 2 spaces are switched from object into world. After you switch it into world, you can see the same thing happens with these other materials. But we don't really want to do that. But if you did, what use would there be in doing that? Well, when you have it set to world and you duplicate one of these things, you can see that these perfectly tile together. And so you can pretty easily block out a level. So although I don't think it'll be perfect, wrong one, if you start like rotating it, so once you get 45 degrees, it clips into a different thing. But still, yeah, you could pretty easily use it for that. So even if you Yeah, because once you rotate it, it starts lining back up again. So even if you rotate it, it still would work. It might not be perfectly tiling on these little sections, but it works. Anyway, let's get to the walkthrough. So first thing I'll do is I will show you how to set up a subgraph. Create shader graph, and then this button right here that says subgraph. This will be example try planar. Open it up. You're left with just a vector4 output. If you want to, you can add multiple outputs to these things, and you change their types by clicking the drop down, but we only need one, so I will just subtract both of these and switch this to, I believe, a vector4 is fine. You could probably just set it to a vector2 as well. In fact, so I'm going to set this to a vector2 because UVs are vector2s. And then we want to start by making two nodes. First, we want the position node, and we also will want the normal vector node. Right now, these are both set to world, which means that it will rotate and kind of have this it'll rotate and the textures will stay in the same spot. So you'll see, look at the top, if I rotate along this X, those textures stay in the same spot. So that's what we'll go with for now. Then we're going to want to normalize these. It's probably not necessary, but it's something I like to do anyway, just out of habit. And then we want an absolute value. And that is because if we do not absolute value this, it will generate the normalized vectors between 1 and -1, but we only want positive values because we're going to be using each of the directions as a mask. So we want it between 1 and 0. Then we want to run it through a split node. A split node works. So a little tip, this yellow connector thing means that there is a vector3 being transferred, which means that when we're splitting this, R, G, and B is X, Y, and Z. So for this thing, though, we only need the X and Y. So we're going to take X and we're going to type in step. And for the edge, we want to set it to 0.5, and this will put us right in the middle. And then we also want to do the same thing for the Y. So step 0.5. And now we are going to do a similar process with the world coordinates. So first thing, we don't need to normalize, we only just need to split it. And then we actually are going to want 3 vector2s. So vector2, we'll leave it unplugged for now so that we can duplicate it, and then we can duplicate it again. Now in this top one, we are going to put in y in the y spot, and z in the x spot, because remember this is x and this is y and this is z. And for the middle one, we are going to want x in the x and y in the y. And for the bottom one, you might have already guessed it, we are going to want the x in the x and the z in the y. Now, I'm going to create a little bit of space. And then we are going to begin the lerping process. So create a lerp node. And for the A, we are going to want to put in the middle vector 2. And the B, we are going to want the bottom vector 2. For time, which is t, we are going to want the bottom step. If it looks like this, you are doing it correctly. And now we want another vector, another lerp. We're going to take the first vector 2, and that's going to go into the B. And then we're going to take the first lerp and put it in the A. And for time, we will want to use the top step. And then you should get a shape that looks like this. And once you've done that, you are completely done. And you can save the asset and input it into any other shader that you want. So just to show, I will get rid of the original object triplanar that was here, and I will put in the example triplanar, which will now appear as a node in your search. And I can just plug that into the UV. This UV connects to all of my noise maps and all of my texture maps. Save asset, go to scene, and you can see that it works exactly like it did before. And that's pretty much all you need to do. But some of you might have a question, and that is, what is with this step value? Wouldn't it make more sense to use a smooth step value? And that is what I thought initially as well, but I will show you what happens when you do that. So if you go smooth step, put it in the in, we'll leave it 0 and 1 because that's fine. Do the same thing right here. Smooth step, in, 0 and 1, and this is going to go into this time value. Now, you can see though, it starts to do this weird twisting motion. It doesn't happen quite so much on the cube until you like reach those 45-degree angles. And the reason this happens is because when you are looking at your cube, the normal mask is working correctly. So, but it's the positions that are messing it up. Because what happens is this, let's say this corner is in 0, 0, 0, and then this one is in the z direction, so it's 0, 0, 1, which means that this becomes 0 and it transitions to 0.5 and then to 1. But then in the x value here, this might be 0, 0, 0 for the x, which means that when you are coming around and twisting, it's trying to sandwich 1 to 0 on the exact same spot, and it ends up creating this weird stretching thing. Anyway, I hope that was a helpful video. See you guys in the next one.